Once we have specification document, we can ask AI to formulate those specs, but it's very hard for humans to express intent into words because of context.
With AI, once you go deep down enough and things get complicated, I think at that point there's a ton of context that is needed and understanding of code flow.
I started with creating markdown tasks manually. The problem with that, it was a huge context and I will not have good success rate and it would be very hard to roll back.
You use ChatGPT, you use Cloud Desktop, whatever. They have memory, they have conversational memory, but that's not the case for the models, right?
Yeah.
AI have APIs.
So we need to continue that context. We need to send that context back to it every time.
Yeah.
The biggest benefit of the spec, because it is readable, we can actually review it.
Yes.
It's different from tests that we theoretically also could declare a source of truth and review it instead of specs. But as we spoke, we don't want to read anyone else's code, and especially the non-technical people that they even cannot.
Yeah.
Spec is different
because
it's readable. In your language, there are hundreds of languages translations of Gherkin spec. You can read it in Urdu if you feel like. And this is suddenly something that everybody around the table can sync on and say, okay, now we can read the spec. It's not painful in English. And we can verify that what's in the spec, it's actually what we wanted to be generated from on-prem. Now, if it's not, we go back and forth, we iterate until it is, or we just fix the spec. It's almost plain language.
And presumably you could almost like use LLM as a judge as well, to some extent, almost to as a final backup to say, look, because people are going to be lazy, right? And I think this is one of those interesting things where even if you look at something like code review, okay, people don't like looking at each other's like at someone else's code, for example, but it's something that the more text, the more change there is, we'll kind of like look at that and go, yeah, that kind of like looks good.
Looks good.
If there's two lines, we're going to be questioning the variable choices and things like that, right? So if there is going to be a big set of tests or a big specification, are we actually going to go through it?
So imagine that you are on a piece of code in your file, and you are working with URLs, and you practice something that's maybe like URL encoding, or like you like ask the result of the AI is giving you some code that relates to that, and you ask it to like secure it, right? And it says, okay, let's do URL encoding, or the other way around, let's do URL decoding, whatever, like it depends on like the current process. Let's say that this is what it suggests, and by the way, that's probably one of the things it should do. So like that's a proper process. But what happens when it is not aware that somewhere up the chain, right? Let's say this is your service, and in some other service you interact with, or the route, the controller, whatever the architecture is, you actually already did a URL encoding. So now you have double URL encoding. And that is potentially like a security vulnerability, like waiting to happen due to the double encoding. And so if the LLM doesn't know to like trace your code paths and say, well, you actually did an encoding before, you should not really reapply the encoding because you could suffer the double encoding injection, then that's going to get you busted. And so that's why it needs more than being just a statistical model. And sometimes like vulnerabilities in most of the cases, honestly, are very nuanced and very complicated. While it's sometimes easy to just demonstrate some code injection, some cross-site scripting that we show in a vulnerability, and there it is. It's usually most of the time vulnerabilities are chained together. They are more complicated. People chain one to another, like a prototype pollution to do code injection, to do command injection, to open a shell. There's like a layered approach when things happen in the real world, rather than what we kind of demo.
We're going to jump into the second half of our conversation, but first, a quick shout out to AI Native DevCon. 2 days of hands-on sessions, deep dives, and honest conversations about what it means to build AI native software. November 18th and 19th in New York, or join virtually from anywhere. Tickets and details at ainativedev.io/devcon. See you there.
The maximum context size, you're just hitting that mark whereby the results based on the amount of context you provide degrades massively, significantly from that.
Yes, this agent have a feature called compaction. This basically tells the agent to make a summary of all of the previous conversation and start with a minimum context from that summary. But the problem is that the instructions that are contained in this summary are half of the ones that you instructed him initially, and you have to most likely start from scratch again because you don't know what he misses.
Okay. So what's next in the spec journey?
So what was next? The immediate next step was to split the big markdown file into smaller tasks. So I would have, similar to how you have in Jira or in Linear or other project management tools, single tasks that just define what has to be built. And I basically translated this into Markdown files because Markdown is a universal language that is plain text with formatting that both humans and agents can understand very well. And agents were actually more effective, and I could easily roll back single tasks at the time.
And you did this manually, or you did this with?
Yes, at the very beginning I was creating manually, and when I reached around 50 manual created tasks, I was like any probably software engineer would try to automate this. How can I automate this manual creation of tasks? So I built BacklogMD for enabling this and have an easy way to create tasks by using your terminal.
So what I'm going to do is I'm going to have a per user map, and I'm going to pass this chat memory advisor. Okay. So up. There we go. And I'll go down here, and then the advisor, the map will say compute if absent user. Right, and I'm just going to create a new one if it doesn't exist, and I'll store it in memory. Now, there's other implementations of this chat memory interface that you can use that will write to different abstractions, right? You can do like Neo4j and JDBC, and I think there's one Redis coming along. I don't know. It's all sorts of JDBC, of course, all that stuff. So, okay, this is an advisor. This is like a filter, right? It's a preprocessor on the requests intended for the model, and basically, as we have a conversation with the model, this will get stored per user in that map, and then it's a transcript in effect of everything we said, and that'll be retransmitted to the model on every subsequent request so that the model remembers, we talked about A, B, and C. When that person asks about A, B, and C, remember it, right? So here we go. So now we go back and we say, my name is Josh. Great. What's my name? Your name is Josh. Fine. How do you do? Right? So it's now got memory. But let's ask. But this is actually kind of a problem, right? Like, which is what's 2 + 2, right? Yeah. Okay. Great. But it's not supposed to be helping people with their homework. It's supposed to be a model to help people adopt a dog. Clearly, we've kind of wandered off in the deep end here.
And this is interesting because you see a ton of companies. What was the there was a couple of big ones. I think one was it
Amazon.
Chrysler or someone where they were basically getting it to like write a bunch of like malicious code and things like that from the sites, which is kind of
Amazon for a moment. I think their app they have an assistant there, and you can actually somebody prompt poisoned it, and got it to generate code for them instead of helping them with shopping.
It was Amazon then,
Anyway, that's not what we want. So we don't want this thing getting too far off in the weeds. We have a mission. We want people to adopt dogs.
Unless you wanted to know how many 2 dogs plus another 2 dogs could be.
Right. Yeah. So what we want to do is to give it a system prompt. The system prompt is the overall tone and tenor. So var system, okay, here we are, and cat desktop talk system. I happen to have a system prompt. Okay, I'll paste that there. You know what I just did that felt wrong? It's the wrong tool. It's the wrong one.
Yeah.
There, that's better.
Do you know? So when you switched from cat to dog there, I was about to make that joke and I thought, oh no, the only reason I know that joke is because you said it last time I saw it a couple of months ago.
I love it. So, okay, that's better, right? So we're going to say, you are an AI-powered assistant to help people adopt a dog from the adoption agency called Pooch Palace, with locations in Antwerp, Seoul, Tokyo, Singapore, Paris, Mumbai, New Delhi, Barcelona, San Francisco, and London. That's where we are, in Devatuk. And information about the dogs available will be presented below. If there's no information, return a polite response suggesting we don't have any dogs available.